Hello everyone, welcome to ExamRat. My name is Shatabdi, I'm a second year medical student. Today's topic is sources of energy. Let's start with the conventional sources of energy. By this term conventional, what does it mean? It basically means that conventional is anything that is easy, right? That is easy, that is very common, right? Like we commonly use it, like buses or autos are a conventional mode of transport. Why? Because most people use it. It is like um, it's it's very cost effective, and you get like you get them easily. Like not even sometimes auto stands. You get running autos. You get running buses. So they are the conventional mode of transport. So conventional is anything that is very easy to get. Okay. So, but then also everything has pros and cons, right? So, as opposed to a private car, you have the whole space to yourself, and in an auto, you have to share the same space with four people. So, anything that is conventional is not always the best choice. So, in this case, we'll also study this is the same thing about energy. Conventional sources of energy are mainly those that we get from fossils, right? Fossil fuels. So now what the problem with that is that it is non-renewable. Like once we exhaust it, we cannot form fossils again in like a million years, right? Because it takes a huge time for plants, animals to decompose and then get buried over layers of soils, and then finally forming fossil, right? It takes a huge amount of time, and honestly for humanity to sustain, we won't have that much time to create new fossils. So there's a limitation to conventional sources of energy, and that is that they are non-renewable. So conventional can also be called as non-renewable. So the growing demand for energy was largely met by fossil fuels, coal and petroleum. Our technologies were also developed for using these energy sources, but these fuels were formed over millions of years ago, and they are only limited reserves. Once we are done with it, we are done with the oil, we cannot reproduce it. They are non-renewable, so we need to conserve them. This is very important. If we were to continue consuming these sources at such alarming rates, we would so soon run out of energy. So that is what I was telling you, that with so many, with how the necessity for fossil fuels have increased with car companies coming with new cars every day, using like we need petrol, we need diesel, right, to for these cars, and for a lot of other machines we need coal for literally everything that we can think of. We need it for the power plants to generate. If we don't have power plants, we won't have energy. If we don't have power plants, if we don't have factories, we won't have literally anything made, be it clothes, be it food, anything. So we have to at some point find some alternatives to conventional sources of energy, because they are, as we mentioned here, they are limited. And if we keep continuing to use them at such alarming rates, then one day we will run out of them. So energy sources can be divided into conventional sources, non-conventional sources. Conventional, as we talked about, coal, petroleum, natural gas, CNG, that is. The only difference between these two and this is that it is a little less polluting, but it is still again conventional source. Non-conventional, we find solar energy, wind energy, biogas, tidal, geothermal, nuclear, atomic. So we can never run out of solar energy because the sun won't disappear one day, right? In the same way, we cannot ever run out of wind energy. Biogas is anything that is produced by living components. Mostly it consists of methane, which we know is formed from carbon, hydrogen. We will never run out of these particular elements because there'll always be hydrogen in the air, carbon dioxide in the air, water in the air, and we'll always be able to produce methane. So in the same way, biogas is also non-conventional. Tidal energy, the oceans will never be like fully freeze. Although global warming, yes, it is a cause of alarm in the poles, but at the same time, we can never run out of seas or oceans, right? So we can never run out of tidal energy. Geothermal energy is what we get from rocks being consolidated, like huge, like the whole concept of volcanoes and how huge amount of lava, molten lava is present beneath the earth. So we can never run out of rocks, right? So in the same way, these are also non-conventional. Nuclear atomic energy also is very easy to understand. We can never run out of atoms because everything is made of atoms. We can always produce atoms. We can always get carbon, hydrogen in their purest forms in or in their mixed forms on the surface of the earth, in air. So we can never run out of nuclear atomic energy. So what our main motives should be is that from now on to always concentrate on these energies and to endorse these energies so that we are able to use these energies in the future, because these are all limited. So burning fossil fuels has other disadvantages too, other than it being limiting. We know that huge amount of air pollution is caused, right, by the burning of coal and petroleum. Oxides of carbon, nitrogen, sulfur are released as they are acidic oxides, right? We know CO2, NO2, they're all acidic oxides. What are acidic oxides? They are oxides which, on reacting with water, produce acids. Weak acids, strong acids, that's different. Now, why is it a problem? It is a problem because H2CO3, then HNO3, H2SO4, these are all not good for our skin, not good for when they fall on our skin and when we are somehow absorbed in the soil also. They lead to acid rain, which affects our water and soil resources as well. If the soil start absorbing acid rain, acid water, then the plants will also not be able to produce glucose in the same way, right? Because we need pure water for that. We don't need H2O dot H2SO4, right? It is polluting. Also, there is the greenhouse effect by the gases like CO2. What is the greenhouse effect? It is basically the fact that all these gases are kind of producing a layer over the earth. So, due to this extra layer that is being produced on the surface of the earth, the disadvantage is that the sun or the heat that is coming, and after getting absorbed, when the remaining heat has to reflect and go back, it is not being able to do so. It is stopped by these layers. So as a result of which this heat is contained in the earth itself. Now why is it harmful? Because it is increasing the relative temperature of the earth, which is not good. Each year you can realize it for yourself that the summers are becoming hotter and hotter, and that is because the climate is being affected hugely by these greenhouse gases. Greenhouse gases are released by cars, our ACs, and a lot of other electrical appliances. Okay, so as and when the total temperature of the earth is increasing, the poles are getting melted, right? Because they are composed of ice, and when you keep supplying heat to them, they'll obviously melt at a point. So sea level is rising. If sea level rises, if ocean level rises, then there will be more chances of flood and even tsunami if it comes to. So greenhouse effect is not at all beneficial to us. So we need to stop or limit the use of these appliances so that there are less greenhouse gases and there is less increase in temperature. So the damage that has already been done, we can't undo it. Sorry, but we can limit ourselves from now. So thermal power plant is also another application of what we just talked about. What happens here is that the water is boiled, right? And water, how will it boil? It will obviously boil with the help of fuel. Steam is being produced as a result of boiling of water. This is huge amount of steam will move the turbine in a huge speed, and we know that mechanical energy getting converted into electrical energy. I think it sounds familiar from the magnetism chapter, right? So what is happening here is that current is being induced. So the mechanical energy through the electrical generator is producing electricity, and that is being used by us or by power plants or other things. So here from water and the fuel burning we are getting electrical energy. So this is another usage of the coal and petroleum burning. Hydropower plant is still, I would say, a little better usage of technologies to reduce the usage of fuels, because here, as you can see, there is no burning involved, but there is obviously building of dams, which again in the long run creates a problem, because dams means increased risk of floods. So what happens here is that due to the production of these dams, it increases the flow of water, it increases the potential energy of water, and increased potential energy means it increases the kinetic energy also. As a result of which, this kinetic energy again helps to um, turn the turbine. Again, the electrical generator will produce the electricity, and then it will go to the power lines, and we'll be able to get it through our electric cable. So it again is the similar process, just that here the burning is not happening. Now we come to non-conventional sources of energy. Okay, so non-conventional means, just as we talked about, conventional are non-renewable. So non-conventional are things which are not that common. They are slowly arising as technology is developing, but they are renewable. Okay. So the conventional consists of coal and wood. Here non-conventional is solar energy or nuclear energy. These are very much important for us. Okay. Before going into that, as we know that biogas is also a source of non-conventional energy. So let's just see how biogas is useful. So organic waste. Organic waste consists of what? It consists of human excreta, plants decomposed, okay, like dead plants, dead animals, all these organic waste, everything. So these are kept in a anaerobic digester. Anaerobic means no oxygen. And when there is no oxygen, what all bacteria will grow here? Here it will grow anaerobic bacteria. So due to the presence of anaerobic bacteria here, what is happening, that they will act on these dead plants, human excreta and all those, and they will release certain gases. Okay. Among these gases, 75% of these gases is methane, CH4. So here you can see that methane is being produced. So now what is happening here is that methane will be combusted or will be reacted with oxygen. So heat will be given, anything being burnt in the presence of oxygen is combustion. So oxygen will come here. So methane, oxygen, and a lot of um, products will be formed. These are the excess products like carbon dioxide, water, but mainly due to the combustion and due to the formation of methane and it reacting with oxygen, huge amount of energy will be produced, which will be harnessed in the form of electrical power. Okay, and again the rest will be dissipated as heat. So that is why this is important, because here, even though carbon dioxide is getting released, but the huge amount of coal and petroleum that was earlier being used to generate power, that is not being used. It is instead being formed by methane. Now we talk about solar energy. It is also a very interesting concept. So solar energy means the energy directly coming from the sun. What is happening here is that the rays of the sun is reflecting through a shiny surface here, and due to the reflection and the direct concentration of light rays on, not directly, there is actually a thin glass or a plastic cover present. So due to this, what is happening here, heat energy is being concentrated, and this heat energy is being used to cook the food. Also, if you can notice here, is that the interior of the box or the solar cooker is black. Now why is it black? Because black has the most absorbing energy, absorbing property rather, right? And it has the least refracting property or reflective or reflective. So you can understand how here, so all the heat energy that is coming here reflecting through the reflector, also coming directly, is being concentrated here, and also it is getting absorbed throughout the whole box or throughout the whole cooker, and being able to heat this container. It is obviously made of steel because steel is a good conductor of heat. So now, apart from solar cooker, solar energy is also used in solar panel. So it is a similar concept where the solar panels convert the sun's energy into electricity, and when it is happening, a control device changes the electricity, enabling it to power the electrical item. So you can see here that the electricity that is being produced is all again coming to our mains. The electricity then passes through a breaker box to outlets into the building. So here, you know, the breaker box or the meter board. So items such as refrigerator and lamp can plug into the outlets for power. So it is very simple how, again, here solar energy is being converted into electricity. There's a huge mechanism produced here, present here, that will convert the solar energy into electrical energy, and then that will be used for power generation. But the problem here is that it is basically not economical because it is very, very expensive. Like the whole placement of the solar energy and the whole mechanism behind it is expensive. Energy from the sea, tidal energy. Number one, due to the gravitational pull of mainly the moon on the spinning earth. We had talked about this when we talked about gravitation, that how the moon, due to its position, due to its rotation around the revolution around the earth in 24 hours, pulls the seas accordingly due to the gravitation pull, and as the result of which there is high tide and low tide. Um, this phenomenon of high and low tides and the difference in sea level gives us the tidal energy. So it is harnessed by constructing a dam across a narrow opening in the sea. The turbine fixed at the opening of the dam converts the tidal energy into the electricity, and you know how it happens through the electrical generator. Similarly, the kinetic energy. So now we talk about the wave energy, where the kinetic energy possessed by huge waves near the seashore can be trapped in a similar manner to generate electricity. Like similarly, like again, building a dam and everything. The waves are generated by strong winds blowing across the sea. We know how windy it is towards the sea. Wave energy would be a viable proposition only where waves are very strong. So this is again a limitation, and that is not everywhere we find strong waves, right? So a variety of devices would have been developed to trap this wave energy and the rotation of the turbine, and again production of electricity through the electric generator. Ocean thermal energy is something of the same thing. The water at the surface of the sea or ocean is heated by the sun, while the water in the deeper sections is relatively cold. How is it heated by the sun? Because it is in direct contact with the sun and evaporation occurs. We know, we've talked about this. This difference in temperature, how this below the sea level, how it is less temperature, and at the surface it is high temperatures. There's a difference, there's a gradient. You know, anything that has a difference creates a gradient. So the difference in the temperature is exploited to obtain energy in ocean thermal energy conservation plants. These plants can operate if the temperature difference between the water surface and the water at depths up to 2 km is 20 degrees Celsius or more. So the difference has to be a minimum of 20 degrees Celsius for the thermal power plant to work. The warm water surface is used to boil a volatile liquid like ammonia. The vapors of the liquid are then used to run the turbine of the generator. So again, a similar thing is happening, that due to the difference in temperature, the warm water surface is again used to boil a volatile liquid. This ammonia is again helping to turn the turbine. Again, electricity is being formed. The energy potential from the sea is quite large, but efficient commercial exploitation is difficult. This whole thing sounds very nice in theory, but to put it into application or to put it into use, it is actually a little difficult. Geothermal energy, what we talked about a while back, how at places there are huge accumulation of rocks which under immense amount of pressure, their temperature increases. We know pressure directly proportional to temperature, so due to that huge amount of pressure and for years and years and years, and also we know that towards the core of the earth the temperature is also huge, so all these create certain hotspots. So what are hotspots? If you dig towards those surfaces, huge amount of water come out which are very very hot on their own. So that is the whole basis of hotspots. So these hotspots or hot springs, the hot water from them is again harnessed and the steam is produced, which again will use the turbine to generate electricity. Okay, and the remaining water that has been cooled down after the production of heat will again go into the soil. Again, it will be hot under the pressure and under the influence of other substances present there, other temperature present there. Again, hot water will be formed, and this is like, but this process is very time consuming, like the cold water again converting into hot water. So this is geothermal energy. Thermal means heat, geo means from the earth in itself. So this is how we use geothermal energy. So it again looks very nice on paper, but to produce it, it actually takes some time. Okay. So nuclear reactor next. As I told you, in nuclear reactor, the main concept is fission or fusion. So fission and fusion. So fission means the breakage or the breaking of one molecule into smaller particles. This creates a huge amount of energy. And fusion means two atoms fusing to form one molecule. Okay, so fission and fusion, these both produce a huge amount of energy that is harnessed in a nuclear reactor, and again through the same concept, steam turbine and generator produce electricity. So here, what is happening here is that this is the fuel rod and this is the moderator rod and a controller rod. So what happens here is that through the fuel rod, basically the atoms are supplied here which undergo fusion and fission, and they basically, the energy produced from there or the heat energy produced from there is then it comes to the heat exchanger, and then it happens so that the water that is being supplied here, this heat acts on this water and produces steam, and then you know the rest process. So the fuel rod is basically important because it produces the atoms, and the control rod is basically there so that the reactions happen in a controlled manner, in a proper manner. And moderator rod, basically, you know what the meaning of moderator is. It basically prevents the excess fission or the excess fusion. Okay, so it prevents the excess heat formation, and if it is by chance formed, it is absorbed by the moderator rod so that the nuclear plant does not burst. So these are the some of the usage of the specific things in the nuclear reactor. Also, a nuclear reactor can be highly dangerous for mankind. So the wastes, the nuclear waste, disposing them should be done very carefully, and that is where we are lacking at this point, because huge amount of radiation is produced by these nuclear reactors which are not being able to contain, because anywhere we put it on the earth, it will produce pollution, and very harmful radiation can, you know already, will produce problems in your skin, in your health, in every way. So nuclear waste disposal is very very important, and something that scientists are still working on. Also, while handling these reactors, you have to wear suits like made of proper lead, which will not in any way expose you to certain atoms because they are very very dangerous. So comparison, now you can see wind energy advantages, disadvantages. Advantages, obviously, it's non-polluting, low cost production, safe and clean, but huge noise pollution. and it sometimes is not that good of, it does not give that good of an electricity and is harmful to birds obviously. Solar energy inexhaustible, non-polluting, but at the same time it's very expensive and it sometimes gets wasted. Tidal energy, again non-polluting, inexhaustible, but it destroys wildlife habitat obviously because we're using so much of water. So at the end of the day, uh, aquatic plant life is also getting, aquatic life, wildlife, plant life is also getting very much affected. Nuclear energy again emits large amount of energy, but it is very risky, generates radioactive waste, and is expensive as well. Biogas, again low cost, easy to operate, make use of bio waste. Bio waste, cow dung, human excreta, everything. And it's low cost as well. How much does it cost really to gather? But greenhouse effect. Why? Because CO2 is getting released. Geothermal energy advantage is obviously clean, eco-friendly, and always available. Or we can never get rid of, we can never get enough of rocks, but disadvantages is that they are very specific. They can be only placed at specific positions where we can get these hot springs or hot spots. So they're located far away from the city and so costly to transport the electricity. Obviously, we have to put up huge towers and huge cables which will transfer the energy, which is like a cumbersome process. So these are some of the comparisons. So with this, we come to the end of the chapter and of the curriculum. So thank you.